In this video, we're going to break down molten electrolysis, what is it, how it works, and how to predict what forms at the electrodes. So let's start. First of all, electrolysis is the process of using electricity to break down a compound into its elements. So if I have a compound XY, electricity is going to break it into X and Y, most probably, most of the time, Y2. Now, if I have X2, Y3, it's going to break it into X and Y2. If I have a compound XY2, it's going to break it into XY2, etc. So it's always breaking the compound into a metal and a diatomic molecule, non-metal, most of the cases. When we talk about molten electrolysis, we're referring to the electrolysis of an ionic compound in its liquid state, where the ions are free to move. So I'm going to start here. I'm going to show you here these several examples: NaCl, CuBr2, Ki, Al2O3, and PbR2. When we talk about molten electrolysis, we refer to the ions of NaCl as Na plus in the liquid state and Cl minus in the liquid state. So, in this example, let me begin with this example. In the electrolysis, we need two electrodes, one positive electrode named the anode and one negative electrode named the cathode. Be careful, that's the opposite of the galvanic cell electrodes. And both of them are usually made of inert material. Inert means a material that does not react. It does not interfere in the reaction. So like graphite, just like the pencils we used in class. So when NaCl molten is added to this electrolysis, automatically the NaCl are going to be attracted toward the cathode, and the chloride ions will be attracted toward the anode. And the reaction, the half reactions, oxidation and reduction, start happening. So at the cathode, it's always a reduction, and the metal, which is in the liquid state, will get reduced into a metal. However, whatever metal we obtain, it is liquid, in the liquid state. So we need to balance +1 electron. So that's the reduction happening at the cathode. And at the anode, the anions attracted to the anode will undergo an oxidation. So Cl minus in our case, which is liquid, will give Cl2. Most of the cases, the anion in the compound, if it's a monoatomic ion, it's going to give you a diatomic molecule. So since I have here 2, I'm going to balance this with 2 and add 2 electrons over here. However, Cl is a gas and Cl minus is a liquid. Now let's take another example so that you get used to it. Copper, bromide, potassium iodide. I have other examples, potassium iodide. I'm also discussing aluminum oxide and lead bromide. Whenever you get a question asking you what is the product obtained, or what is discharged at the anode and what is discharged at the cathode, or it could be asking you write the half equation of the reduction or write the half equation of the anode, it's all the same concept. The first one is at the cathode, obtained, and the second one is discharged in the form of a diatomic molecule at the anode. So in the molten electrolysis of copper bromide, at the cathode we get Cu, and at the anode we get Br2, and so on. It's like that. Now here I have placed a table where I am indicating the physical states of the metals deposited at the cathode. So aluminium, lead, and copper are the one obtained in the solid state, whereas potassium, sodium, and other metals are in the liquid state. So here, this is in the solid state, copper. Yes, so solid state. Now bromine is in the is obtained in the gaseous state. If I took the other example, Ki, we get K liquid state, and I2 at the anode, solid. Aluminium oxide, we get aluminium, so as I wrote here in the table, it's in the solid state at the cathode, and oxygen gas at the anode. Lead will be obtained as a liquid metal, see, and bromine, I'll get bromine as a gas. So it's very easy. You just look at the formula given to you and you can say these are the products discharged at the cathode and at the anode. And whenever they ask you to write the half ionic equations, I'll repeat again with the example of Al2O3. So Al2O3, at the cathode, I have the positive metal obtained. So Al, now Al is belonging to group 13, so it's going to be 3 plus. Liquid is going to give Al solid. Now I have here 3 positive charges, so 3 electron. Regardless of the charge of the metal, you always get the metal without any a monoatomic metal. Now at the anode, it's the other one. Whatever ion you have, oxygen is O2 negative. So here, O2 minus is gonna discharge, it's going to get oxidized and discharge oxygen gas molecules. It's always 2. So whatever anion I have, I'm gonna get a diatomic molecule. Now we need to balance this. Since here I have 2 oxygen, so 2 and plus 4 electrons on the other side. I'm gonna move this a little bit to have some space. Oxygen gas and 4 electrons for balancing. And that's it for the molten analysis, electrolysis of molten ionic compound.